function form down here so I'll have it closer to me. All right, so what this tells us is this. If I'm going to draw I'm going to graph this function right here. Well, that tells me that the slope is what? 5. And what is the y-intercept? Okay, so my slope is the 5, and my y-intercept is that 5. Okay, so when I graph that, you get this. 1, 2, 3, 4, 5. So there's my y-intercept right there. Okay, now the line is a positive slope. Okay, so that means my slope goes like this. All right, it's a positive slope. So my slope, we said, slope is equal to 5. So that's 5 over 1, which is your rise over your run. Okay, and so that means I've got to go down. I've got to go down 1, 2, 3, 4, 5, and over 1. That is correct. But if I'm going down, down is negative, and to the left is negative. That's how we get our positive slope. And therefore, I take a line and I draw it through that point and through that point there. And sure enough, we have proved graphically, that is my answer. It did cross the x-axis using my information of slope being 5 and my y-intercept being 5. It did cross the x-axis at -1. And so we proved it. We proved graphically this being true. Okay, Matthew? No, we don't want to go up because we want to see where it crosses the x-axis. So if we go up and do our slope up, we're never going to cross the x-axis. Well, they're all going to be different. They're all going to be different. But okay, I understand what you're saying. Yes, unless you were going, well, no, not really. Because if you look at your quadrants, 1, 2, 3, and 4, if I have a point that starts down here, I've got to go up to get to my x-axis. If I've got a point that starts here, then I've got to go up to get to my x-axis. So they're just all going to be different. I can't really say that, yes, you're always going to go down, because that's not obviously true. The only time you're going to go down is when you're on the y-axis. Now, obviously, we're always starting on the y-axis. So if it's here, you're going to go down this way. If it's here, then you're going to have to go up to get to the x-axis. Okay? All right, let's look at another one. All right, let's look at let's look at this one. I'll look at one with fractions in it. -2/3 x minus 6 equal -4. Okay? Now, the reason that we've got to change it to x plus something equals 0 is because we need to be able to get it in function form to actually get the graph of our equation. Okay, so we've got to take this -4 and bring it over. Here it was a negative. Here it becomes a positive. So what I then have is -2/3 x minus 6 plus 4 equal 0. Okay, well, remember this is plus negative. So what is negative 6 plus positive 4, Zach? Okay, so that gives me negative 2/3 x plus negative 2 equals 0. Okay, so that in function form, would give us y equal negative 2/3 x plus negative 2. All right, now that we have our function form, we need to go back and solve for x, because they want us to do this algebraically first. Okay, they don't want you to do the, basically they don't want you to do it on a graph and then come back and get what your answer is. We'll do that here in a second. All right, so we need to solve for x. So negative 2/3 x plus negative 2 equals 0. So I've got to take the negative 2 over here, becomes a positive 2. So it's negative 2/3 x equal 2. Now, how do I get rid of the negative 2/3? Nick, what I got to do to get rid of the negative 2/3 x? What do we do with the fraction in front of the variable? How do we solve a fraction in front of the variable? Multiply by what? Yeah, multiply by the reciprocal. So we got to multiply by the reciprocal, which is negative 3/2 to both sides. Okay, so you multiply there, you multiply by negative 3/2 here. Okay, over here it cancels. All right, and that leaves me with x on that side. Over here, I have 2's that cancel, and that leaves me with what? Negative 3. So x is equal to negative 3. All right, now we have to prove that graphically. Okay, I'm going to try to just draw it here. Let's see. We're starting on negative 2 on the y-intercept. Okay, so I'm going to go with this. I'm going to go here and here. Since it looks like I'm staying in quadrant 3, I just drew quadrant 3, okay, instead of drawing a big graph. So my slope, my function form says that my y-intercept is negative 2. So negative 2 is right here. Okay, that is 0, negative 2. And that is the y-intercept. All right, now my slope, my slope then, slope is equal to negative 2/3. So negative means that my line is going to go like this. It's going to fall from left to right. So my slope is negative 2/3. So that means I'm going to go up 2, 1, 2, and I'm going to the left 3. 1, 2, 3. And then so therefore my line, my line does prove graphically, we do prove that x is negative 3. Okay. Let's look at one more from that section. 28 is 2/3 x minus 2/3 equals 2. Okay, so let's solve this put it in function form. So step number 1 is to put it in function form. It was positive here, so it becomes a negative here. So that gives me 2/3 x plus negative 2/3 plus negative 2 equal 0. Well, negative 2/3 plus negative 2 would give me what? Say what? Well, what is it? What is it mixed number wise first? Yeah, negative 2 and 2/3. You have 2/3 x plus negative 2 and 2/3, but we've got to have it as an improper fraction. Okay, which is, negative, that's positive 2/3 x, yeah, plus negative 8/6. 2 times 3 is what? Plus 2. 8. Oh, my bad, 8/3. Thank you. 3. You got me that way. Hey, maybe we just ought to have no homework. Nick actually caught me making a mistake. Nah, we'll have homework. All right. So, there's your function form. We put it in function form. And that's y equal 2/3 x plus negative 8/3. All right, now this one's a little bit more difficult to graph just simply because it is, but I got to solve it first, right? Got to solve it. All right, we got to solve it. So we have 2/3 x plus negative 8/3 equals 0. So I have to take the negative 8/3 to the other side. It was a negative here, becomes a positive there. So that gives me 2/3 x is equal to 8/3. All right, now you take that, 3/2, 3/2, because we're doing the reciprocal. Okay, and that gives me 3's cancel, 2's cancel, leaving me with x. 2 into 2 goes once, 2 into 8 goes 4 times, 3 and 3 cancel, giving me x is equal to 4. Now, this one here to graph is a little difficult. Where do we start? Negative thirds. So, let's do this since we're dealing with those two quadrants. There. And there. All right. So here's my y-intercept, negative 8/3, okay, which gets me 1, 2, right there. Okay, that's 2 2/3 basically. All right, now my slope is 2/3. So I'm going to go up 2, 1, 2, and I'm going to go over 3. Okay, so I'm going to go up 1. Hang on here, let me erase those dots because I got to get it right. I'm going to go up 1 and then 2. Okay, and then I'm going to go over 3. So 1, 2, 3. Right there. There's your first point. Okay, now I've got to go up 2, 1, 2, and over 3. 1, 2, 3. There's your third point. Now, when you connect that together, when you connect those dots together, you're going to prove it because 1, 2, 3, 4. That's where it crosses the x-axis. So we proved it graphically that it is 4. That one's harder because you start in a fractional form on the y-intercept, and so you have to continue. These points have to be 2/3 on the line, okay, just like your original one started down here. Yes, Matthew? Yeah. We have to go up 2, so we're starting here, so to go right there would be 1. Okay? In other words, you're going to be at negative 1 1/3, okay? And then to go here, that would be my second 1, and that would be negative 1/3. Okay? And then I went over 3 from there. I have to stay 1/3 right there. All in quadrant 3? No, you can't. Can't be in quadrant 3 because you got 1, 2. You can't be in quadrant 3 because it's a positive slope. You went negative slope. See right here, this is going up, which is positive, and going to the right, which is positive, which creates my positive slope. So if you ended up over here, you'd go up as positive, and then over here would be negative. So you'd have a negative slope line. Okay? All right, now, got to move quickly on this next part. All right, let's look at number 30. Number 30 says 5x minus 2 equal 8. Okay, so take the 8 over here, it becomes a negative. It's a positive here, becomes a negative there. So that's 5x plus negative 2 plus negative 8 equal 0. And so what is 5x plus negative 2 plus negative 8? What? Negative 10. So 5x plus negative 10 equals 0. So your function form is y equal 5x plus negative 10. Now, they want you to solve it graphically. So that means they want me to go ahead and put on here okay, so I'm going to make these 2, 4, 6, 8, 10, 2, 4, 6, 8. Okay, those are obviously negative going down. Okay, and so my y-intercept is negative 10. So I go down here on negative 10, put my y-intercept. My slope is 5 over 1, which once again is rise over run. Whoa, go back up. Rise over run. So that means I'm going to go, and it's a positive slope, so I'm going to go up 1, 2, whoops, hang on here. I go up 5, so that's going to be 2, 4, 5, and I'm going to go over 1. Okay, which puts us right there. Okay, and then I'm going to go, oh, that is 2, my bad, thank you. Got to go here. Then I got to go up 1, 3, 5, and over 1. So there's your line. So x equals 2. Okay, that's what I just proved graphically. Now I got to prove it algebraically. 5x plus negative 10 equals 0. Take the 10 over here, it becomes a positive. That gives me 5x is equal to 10. Divide by 5, divide by 5, x equal 2. All right, so we proved it graphically and algebraically. So your homework.
38 to 44.
No.
All calculators. 1 through 2
Even if you don't need a calculator for that.
1 through 2 multiples of 3.
All right, let's see. Hey, not bad. 20 through 37. 20 through 37. But we didn't solve it. We just put it in function form. So 4.7, 20 through 37. Yeah, you can go.
Well, you already walked out the door, so I guess.
Blake, I will get you a book. What class do you have next? What does he have, band? Art? Okay. I'll bring it to you in art. Yeah.